Hello everyone, +2 here. This is gonna be the last video I make this year. I thank you for those who follow my channel, and I really hope that my videos help you uh, a lot, right? I also hope that you have a relaxing and wonderful Christmas season. And remember, Christmas is all about Jesus Christ, eh? Right. Question C. The graph below shows part of the graph of h of x equals the sine e to the power of x. So it looks like this. Find the value of a limit x approaches negative infinite, h of x, and the limit h of x approaches positive infinite, or state clearly if any do not exist. Support your answer with the mathematical reasoning. All right. Let's start with when x approaches minus infinity. So that way. So as you see, this since left-hand side resembles e to the power of x. So I'm going to write it down. So since left hand, my writing is ugly, hand side resembles e to the power of x is an exponential graph. Limit x approaches to negative infinite, h over x must be what? So if it carries on that way, it's got to be toward 0, isn't it? So limit h over x, x approaches negative infinite, must be 0. So x-axis becomes horizontal asymptote, isn't it? And what about that way? So if it approaches that way, positive infinite, right hand side is like sine x. It oscillates. Okay, um, amplitude must be the same, but you can try on decimals. It that period is shorter and shorter, but oscillates. So I'm gonna write it this way. So and right hand side of h of x is like sine of x, and the function oscillates. Hence, limit x approaches positive infinite, h of x doesn't exist, right? So it's not towards any number because it oscillates up and down and up and down. Hence, in this case, um, limit doesn't exist. Okay, that should be the answer. All right, next question. Find the exact value of a that generates the maximum value of the definite integral. R equals integral from a to a plus 1 sine e to the power of x dx. So you may use graph above to justify your answer. So when you see the graph, so as I said, that oscillates, right? So this is a negative part, and that is positive part. So right hand side doesn't give you any like a positive area, right? So because it cancels out, right? So only positive part is this area, yeah. So to be honest, I thought about finding x-intercept, but that's my assumption. So I'm saying a plus 1 must be x-intercept, but who knows? It's still so somewhere. So I'm saying if I know x-intercept, well, that's kind of easy to find it. So that area is the maximum area. That's my thought, but I can't just assume, right? I have to prove it. So that's not right approach. Instead, um, do you know, so like to find maximum like a value, you have to differentiate, right? Differentiate the function I. So we have to find the di dx. So which means we have to differentiate this integral, right? So do you know that is just sine e to the power of a plus 1 minus sine e to the power of a, isn't it? Right? So because we differentiate and find maximize it, so it's got to be 0, isn't it? So that means e to the power of a plus 1 minus e to the power of a equals 0. So because e to the power of a plus 1 should be same as e to the power of a. However, we know that a minus, a plus 1, isn't it? A plus 1, is it a plus 1? That's right. A plus 1 is not a. They are different, obviously. So what we have to do is use a general solution. So what I mean is e to the power of a plus 1 equals n pi plus minus 1 to the power of n e to the power of a. That's the general solution for sine graph. Okay, so then obviously n can't be 0 in this case. That's like I already explained. A plus 1 is not a. So let's do n equals 1. So at n equals 1, e to the power of a plus 1 must be, so when you plug a 1 here, pi minus e to the power of a, isn't it? So that means e to the power of a plus 1 plus e to the power of a equals pi. So we factorize by e to the power of a. Oops. So that's a e plus 1 equals pi. So hence e to the power of a equals pi over e plus 1, right? So what do we have to do to find the a? Put ln on both sides. So therefore a is, so ln is 1, so a is ln pi over e plus 1. So if I plug that into your calculator, it is approximately minus 0.1685, right? For your information, hence a plus 1 is 0.8315. Have a look at the graph. So that makes sense. So it's 0.8315, so about 2468, yep, here, somewhere, and start from there. So this is a minus 0.1685 and up to 0.8315 gives you maximum area. Yep, that makes sense. Cool. All right, I'm glad that I finished it till the last question. And on the way, I mentioned before, Dr. Wayne Burroughs helps me a lot. So I appreciate his help, kind help. All right, I will see you next year. Merry Christmas and a Happy New Year. Bye.